Hello everyone. Today we will be exploring Cloudflare Pingora. Uh, in later video we can talk about NGINX and what is NGINX. In this we would explore Pingora. Let's go through the article that they have shared, and then we can go to basically their site. So let's start with this. Open sourcing Pingora or Rust framework, how we build Pingora, the proxy that connects Cloudflare to this. Let's get started with the first one, how we built Pingora and the proxy. So what is a proxy? Uh, and parallelly, I would suggest we continue with some drawings as well. So, or we can possibly shuffle this. Mm, Yeah, we need this. Okay, let's get started. We'll go through how Cloudflare built Pingora, the proxy that connects Cloudflare to the internet. So in simple terms, I would say uh, we can think of it like this. If we have any application, let's say front-end application, right? Here we have any, or I would rather use this text, front-end application, right? If we have any front-end application and we have a server for it, which is residing somewhere, which is backend server, what happens is you can directly communicate, like you can directly request for any data and it can go to this and come back directly from this. But in between there sits a lot of other services as well, like proxy, load balancer, and a lot many others. So here is basically where proxy sits. This is the simple pro proxy, we'll say. So it sits between this. So any request which goes to backend server or comes back needs to go to through the proxy itself. So we'll go through the article itself. Today we are excited to talk about Pingora, a new HTTP proxy. Okay, we have built in-house using Rust. So the tech choices that they have taken is used Rust. Next is Rust that serves over 1 trillion requests a day. That's a really huge number of requests, which is 1 trillion requests per day. That is what they serve. Boosts our performance and enables many new features for Cloudflare customers. Okay, so all while requiring only 1/3 of a CPU and memory resources for our previous proxy infrastructure. So basically they had earlier they had this Nginx Nginx based proxy setup infra, and now they have their in-house Pingora based proxy infra. So these are the two, and in their opinion, so we can keep this at top and we can keep it here. In their opinion, when they started using this, it enabled many new features. So here they got new allowed new feature addition. First thing. Second thing, it takes 1/3 of CPU and memory, and other than that, it boosts their performance as well. So let's go in more detail. As Cloudflare has scaled, we have outgrown NGINX. So basically, they are saying like NGINX is basically meant for proxy, but not at the scale that Cloudflare is working on. So they had to basically pick like they had to choose a new approach for it because Nginx was not working for them. It was great for many years, but over time, its limitation at our scale meant building something new made sense. We could no longer get the performance we needed, nor did Nginx have the features we needed for our very complex environment. Okay, so there were features issues and performance. What if they acquired Nginx? That not sure if that could have been the possibility or not. Next is many Cloudflare customers and users use Cloudflare global network as a proxy between HTTP client. Okay, interesting. So they are saying that if we have this application, front end application, uh, this is our, let's say, backend application. They are saying that they have a proxy which sits here. Let's say I told you that there is a proxy, right? So they are saying that there are a lot of applications which are using Cloudflare proxy. Cloudflare proxy is being used here. So many Cloudflare customers and users use the Cloudflare global network. Cloudflare global network. Okay. uh, Proxy between such as a web browser. Here we could have a web browser IoT. Here we could have a web browser IoT or other devices which needs to connect to a server, and there is a server. In the past, we have talked a lot about how browser and other user agents connect to our network. We have developed a lot of technologies and implemented a protocol. They have implemented some protocol QUIC and optimizations for HTTP2 to make this leg of the connections more efficient. Okay, so they basically try to evolve the HTTP, like optimize HTTP2 itself, and lot of technology implemented new protocol. Okay, okay. So today we are focusing on different parts of the equation. The service that proxies traffic between and the server, our network and server on the internet. So they are basically talking about this part itself, uh, different parts of the equations. This proxy server powers our CDN, workers fetch, tunnel, streams, R2, and many other features and products. Okay. So they are using this proxy for many things. Let's dig into on why we choose to replace our legacy service and how we develop Pingora, our new system designed specifically for Cloudflare customer use cases and scale. Why build a yet another proxy? Over the year, our usage of NGINX have run up against limitations. For some limitation, we optimized or worked around them, but others were much harder to overcome. Agree to that. Uh, Architectural limitation had performed the NGINX worker architecture. So they had a issue with NGINX limitations of NGINX. First is worker or process architecture has an operational drawback for our use cases that hurts our performance and efficiency. First, in Nginx, each request can only be served by single worker. So, in Nginx, if there is a request which comes from the front end or somewhere from some device, there is a single worker assigned and it can be taken by that worker itself. This results in unbalanced load across all CPU cores. Okay, which leads to a slowness. We'll come to this. They are saying like first we need to understand what is a single worker. Because of this request process spinning effect, requests that do CPU heavy and blocking IO tasks can slow down other requests. Okay. As this blog post test, we have spent a lot of time working around this problem. The most critical problem for our use case is a poor connection reuse. Okay. As per them, this is the most critical problem as coming from their architecture, Nginx architecture. Our machine establishes TCP connection to origin server to proxy HTTP request. Okay. Connection reuse speeds TTFB of request by reusing previously established connection. However, the Nginx connection pool is a per worker. What is a worker? Interesting. The Nginx process model is they have a master process, child processes, and they have a cache manager, cache loader, and they have a multiple workers. Worker processes handle HTTP and other network traffic. To better understand this, you need to understand how is Nginx. Nginx has a master process and a number of workers helper processes. Okay, a service Nginx restart, PS, EF forest on this. Why is architecture important? On this four core server, the Nginx master process creates four worker process. Okay. Why is the architecture important? The fundamental basis of any Unix application is the thread or a process. From the Linux OS perspective, threads and processes are mostly identical. The major difference is the degree to which they share memory. A thread or process is a self-contained set of instructions that the operating system can schedule to run on the CPU core. Threads and processes make it easy to do parallel operations in, so for example, to handle multiple connections at the same time. Process and threads consume resources. They each use memory and other OS resources, and they need to be swapped on or off the codes. An operation called context switching. Most modern server can handle hundreds of small active threads or processes simultaneously, but performance degrades seriously since once memory is exhausted, or when high I/O load causes a large volume of context switching. The common way to design network application is to assign a thread or process to each connection. Okay, this architecture is simpler, but it does not scale when the application need to handle thousands of simultaneous connections. NGINX uses a predictable process model that is tuned to be available hardware resource. The master process performs a privileged operation such as reading configuration, binding to put in a small number of child processes. The cache loader process runs as a starter to load the disk-based cache into memory and then exists. It is scheduled conservatively. Cache manager runs typically prunes entries from the disk cache to keep them within the configured size. Okay. One worker process per CPU process. When Nginx server is active, only these worker processes are busy. Each worker process handles multiple connections in a non-blocking fashion, reducing the number of context switches. Each worker processes a single thread and runs independently, grabbing new connections and processing them. This process can communicate using shared memory for shared cache data, session for system data, and other shared resources. So there is web, email, TCP, or any traffic, stream state machines, HTTP state machines, mail state machines, any data, and non-blocking the static content discussion access log to discussing log. Each Nginx worker process is initialized with Nginx configuration is portable setup. Listen supports by the master process. The Nginx worker processes begins by waiting for the event on the listen socket. Events are initialized by new incoming connection. These connections are assigned to state machine. There should be state machine most commonly used, but Nginx also implements state machine for the stream traffic and for the number of mail protocol. So, state machine apply rate perform authentication and this scheduling the state machine. Think of the state machine like the rules for the chess. Each SGP transaction is a chess game. On one side of chessboard is the web server, a grandmaster who can make decisions very quickly. On the other side is the remote client, the web browser that is accessing the site or applications over a relatively slow application. However, the rules of the game can be with web server might need to communicate with other proxy parties or talk to basically authentication server. Blocking. Recall our discussion of process or threads as a self-contained set of instructions that is operation system can schedule to run on a CPU core. Most web server and web applications use a process per connection or a thread per connection or during the time the process is run by the server, it spends most of the time blocked waiting for the client to complete its loop. The web server process listens for the new connections. On the listener, when it gets a new game, it plays the game blocking after each move to wait for the client's response. When the game completes, the web server process might wait to see if the client wants to start and if the connection is closed. The web server process return to listening to new game. Okay, perhaps you have You have heard of a simultaneous execution game where one chess master plays dozens of opponents at the same time. That's how NGINX worker plays chess. Each worker is a grandmaster that can play hundreds, in fact, thousands of games simultaneously. The worker wait for the event on the listen and connection sockets. Events occurs on the socket and the worker handles them. An event on the listen socket means the client has started a new chess game. The worker creates a new connection socket. An event on the connection socket means the client has made a new move. The worker responds by it. The worker never blocks on a network traffic waiting for its opponent to respond. When it has made its move, the worker immediately proceeds to other games where moves are waiting to be made. Faster than blocking multi process Arca engineer scales very well to support hundreds of thousands of connections per worker process. Each new connection creates another file descriptor and consumes a small set of additional memory in a worker's where there is a very little additional overhead per connection. Nginx process can even pin to CPU. Context switches are relatively infrequent and occur when there is no to be in the blocking connection per processor. But for more detailed check out those updating configuration and upgrade. So, what I have understood so far, let me mm, let's create the architecture of Nginx. This is okay. I would say let's go to this. There is a master, and then there are, let's say, multi-core. A system is a multi-core application. So let's say it has two core or three core, whatever number of cores it has. So depending on number of cores, Nginx even though allows us allows to configuration. So core can be configured like core 1, core 2, core 3. And this is and on top of it there is a, process parent process root process which is active. And on here on the left side we can have a multiple client. We can have a client, uh, web client 1, let's say. Similarly we can have a web client 2, let's say, or we can have a mail client, web client, mail client 1, mail client 2. So uh, we are just trying to decode what we have understood. So here is a client. When it requests anything, so as it let's say all of these clients knows the address of this Nginx server itself. So they all can request this Nginx server, right? And whenever a request comes up, Nginx server assigns a particular code to it. So let's say this is assigned to this core, this is assigned to this core, right? This is assigned to this core, like that. And let's say it's waiting, right? So it assigns a processes or codes or processes, I would say, process 1, process 2, and process 3. Now what happens is it needs to establish a connection every time. every time it needs to create a connection. So let's say this was trying to access some let's say api.example.com, right? One or two. Let's say P1 needs data from this, so it needs to create a connection with it, and this connection is created. So it would send a request and wait for the response, and similarly it would and I'm still not able to get if connection web client 1 requires something. So let's see what they are trying to explain clearly. That's how NGINX workers plays a game. Each worker, remember, they are usually one worker for each CPU core. So we have created each worker for each CPU core, and we have three different core. Is a grandmaster that can play 100, in fact this. So and there is a connection sockets, events on a connection socket. This NGINX workers can process hundreds and thousands of active connections at the same time. Ta-da. So one thing is like when web client 1 wants to connect to let's say this one, so it can directly go like this. It requests some content from this, as this is a proxy, so it needs to create a connection with this, and then wait for data, and once data is received, then trans return this data back, right? That is its job, because it's a proxy, reverse proxy, which is sitting in between. Similarly, if mail clients ask for data which needs to come from P2, it can request here, and then it can wait for data to come, and once data has come, it can give it here and can go back here. This way, it cannot allow multiple connection at the same time. So to unblock this, what they have created is they have created a pool where all the connections are registered and all the events are thrown basically. As soon as someone wants to connect, this is thrown here. Anybody who is free, listen to this, subscribe to this, and they are connected to this. And now they send data for this. As soon as data is received, it's processed and given back. Similarly for 2, if request has come, P1 would create a connection, like request for the data and wait for the data to come on this, and it would continue similar to what they have called a grandmaster. So this is acting like a grandmaster, and then there are uh, multiple clients who are playing chess. These are chess boards, and these are multiple clients. So if anybody like if there is any movement from this, or if there is any movement from this, it can directly respond in a non-blocking fashion, because it's driven on this. So any response that comes up from here goes through this bus, and it's picked by it, and it goes here. But the only problem that Cloudflare have raised over this is, if let's say given each worker has only one, each core would have one worker, and the problem is like if this request come to P1 and P1 is processing this, and let's say P1 is occupied with some other task, and now this request goes to P2 because it is trying to load balance. If the same request this goes to P2, then P2 needs to connect with API dot ex2.com as well. If that the case, what is happening is the concern that they have raised, the Cloudflare uh, team have felt is they are not able to reuse this connection. Once the connection is created between P1 and this, and again when P2 wants to connect, it needs to create a connection again because they are not able to reuse the connections between the processes. So I guess that is what they had pointed out, which was mentioned here. Uh, I guess we went to down. Yeah, the most critical problem for our use case is a poor connection reuse. Each one is connecting to each server, and this is happening again and again. And if it is happening again and again, there is no connection reuse. Our machine establishes a TCP connection. So this is their machine, which is acting as a proxy. TCP connection to origin server, and to proxy HTTP request. Connection reuse. Now what they have tried to introduce is they have put a another pool which is of connection reuse. So if there is any connection created, it's stored here, and the details are already there. So if same connection is needs to be created, so they can reuse the same connection itself. And how they are doing is they are trying to use a multi-threading approach within a process itself. So we'll go through it. Connection reuse speeds up TTFB of request by using previously established connection from uh, pool, previously established connection from a connection pool, skipping TCP and TLS handshake. So if P1 has already connected with api.ex2.com and P2 again wants to connect, so this needs to again do the TCP connection and TLS handshake, which can be avoided if the connection can be reused. However, the NGINX connection pool is a per worker. They like each worker needs to connect independently. When a request lands on a certain worker, it can only reuse the connection within that worker. So which means they are saying this: if web client 1 request went to P1 and P1 connected to api.ex2.com, and again if the request goes to same worker, then only connection reuse is possible. But if it goes to another worker, then connection reuse is not done with Nginx. When we add more Nginx workers to scale up, if they try to add more P4, P5, P6, our connection reuse ratio gets worse. Yes, that would happen because connection is not reused at all. So that ratio would get worse. The result is slower TT time to first byte and more connections to maintain, which consumes resources as you are unnecessarily creating duplicate connections. You are connecting to same server, but you have a different connection, so you are utilizing resources, which is correct. So you are unnecessarily utilizing CPU and memory. I guess that was the reason they were able to do it in one third of the CPU and memory. And second is you need to manage too much of connections, which could be avoided. So here is the diagram that they have provided. So in Nginx you have multiple clients, and each client, this is a Nginx which has uh, with the connection pools they are saying workers, I guess. So when a request goes to a connection one, it creates a new different handshake, connection two, different handshake, and different handshake, even though the server is same. As mentioned in the past blog, we have worked around. Okay, some types of functionalities are second issues that another issues that they have raised is it's difficult to add functionalities to Nginx. Nginx is very good web server. Okay, Nginx is a web server, load balancer, or simple gateway. Yeah, it's a gateway because all the traffic is going through it, so it can act as a gateway. It can decide to allow entry or not. It can act as a load balancer as well. It can decide if a request should go to a P1, P2, or P3. uh, and it's a web server because you are able to get like you are able to request something and get a response, and it is doing some processing in between, even though it's a very a little bit of processing, which is I would say dumb processing, but still it's a web server. But Cloudflare does way more than that. We used to build all the functionality we needed around NGINX, which is not easy to do while trying not to diverge too much from the NGINX. For example, when retrying and failing over a request, sometimes we want to send a request to a different origin with a different set of requested. Interesting. But that is not something Nginx allows us to do. In cases like that, we spend time and effort on working around Nginx constraint. So it's saying that, let's say it tries to connect to api.ex to .com to get some details to a customer client, and it was not able to. So if it redirects that request to some another server, so it would not be able to update the header and other details to get it done. So uh, this requires manual efforts like workarounds. Nginx by default does not allow this. Meanwhile, the programming languages we had to work with didn't provide help elevating the difficulty. So they were having difficulty with programming languages. Nginx is purely in C, which is not merely safe by design. Yeah, it may not have a safety, type safety, memory safety. It is a very error prone to work with, such as a third party code base. It's, yeah, third party code base you would struggle because it's not type safe. It's quite easy to get into memory safety issues even for experienced engineer. Agree. At that scale, if you are working, you could get into the memory safety issues. And at the scale of this, you need to handle garbage collection and everything in detail. Memory safe, like memory can choke up at any point of time. The other languages we use to complement C is Lua. It is less risky, but also less performant. In addition, we often found ourselves missing static typing when working with complicated Lua code and business logic. And the Nginx community is not active. Development tends to. Okay. So as per them, they tried Lua, but again, very difficulty. No static typing. They received either from Dua or from C, and less active Nginx community. Over the past few years, we have continued to grow our customer base. So there are three different options. Either invest in Nginx, yeah, which I recommended earlier. They could either buy or invest in Nginx in terms of I get tech or in terms of finances or whatever, and possibly fork it and optimize it. But the issues that they were facing is they were having issues on the architecture limitations level. So even though they would put effort, it would require a lot of rebuild and lot of workaround. Second is migrate to another third party proxy. Like other companies have also struggled and created their own customs, but they have again their own pros and cons. So but the issue with this is, like, if they go back to this approach tomorrow, they would be in the same state. Currently they are using nginx, and nginx is not able to provide all the features and everything that they need. Similarly, other packages may not be able to do the same. Say third, start with the clean and create your own. And they found that this is the option. Like they were trying to avoid this option, but later found that this is more worthy investment than others. Design decisions. Uh, they wanted to make a proxy that serves millions of requests per second. Yeah, there were trillions of requests per day, which means if there were trillions of requests, so if I say if I say like this, 1 trillion requests 1 day, and 1 day would have 24 hours, and 24 hours would have 24 hours. Each hours would have 60 minutes, and each minutes would have 60 seconds. And if you do the math, it's 86,400. So, which is 86,400. So if we do this, and 1 trillion would have 9 zeros. No, billion would have million, billion, trillion. So this is 6, 9, and this will be 12 zeros. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divided by, if we just walk around this and we say 2, 3, 4, 5 zeros. And if we just remove 5 zeros, still we are with 1, 2, 3, 4, 5, 6. We are still with 10 millions requests per second. So they are correct. They would need millions of requests per second. And efficient, we have to make a few important decisions here. They choose Rust because C was not memory safe, and it was having a lot of performance compromises. And Rust is way performant than C, although there were some other libraries, but they for the HTTP there were other libraries, but they choose to build their own to maximize the flexibility so that they can handle the HTTP traffic and more innovate can their end. Another thing is that they wanted to as they are handling traffic of entire internet. There are applications or there are services which does not where request does not comply with RFC, so they need to support non-RFC compliant request as well. There have been a lot of discussions around this, uh, and there is a issue being raised. Normally this is the status that is allowed, but there are like past services which uses this, and Cloudflare still supports it. And in community there have been a discussion about this, and some tools have agreed to basically allow this, but they can choose not to. So to avoid these situations, they have tried to build their own HTTP. It's a wrapper or package itself. Here mentioned, while hyper team ultimately accept the change, there would have been a valid reason. They could have chosen a valid reason to reject this as well. So if they want to allow satisfy the constraints of the Cloudflare position, they would allow all the options. So that was the reason they choose their own custom HTTP wrapper as well. The next design decision was around workload scheduling. If they should go with the workers approach that NGINX is using, which is multi-processing, but they choose multi-threading in order to share resources. The same thing because they wanted to use reuse the utilize the connection reuse. So they went with multi-threading where a single process can instantiate multiple threads, and all the resources and everything can be utilized by those threads, can be shared by those. And because they wanted their project to be intuitive to developer, they implemented life of a request, basically a life cycle framework, so that you could plug in the same that NGINX was talking as a state machine thing, request filter phase, and then developer group. So they make it easy that you can easily switch between Nginx and Pingora. Pingora is faster in production. Let's fast forward to 2%. Pingora handles almost every HTTP request, and they were able to reduce the median average TTFB by 5 seconds, and 95 percentile like 95% users request TTFB have been reduced by 80 milliseconds. So these savings come from new architecture which can share connection across one thread. So this is like this. There are clients which are requesting resources through Nginx proxy to a server. So this there is a connection pool that is being used. So all the threads can use the same connection which has been established with the server. And with this, they are saying that we save our customers and users 434 years of handshake time every day. So every day they are saving that much because given they have a lot of traffic coming to. So if we can check traffic to Cloudflare per second, handles an average of over 63 million HTTP requests per second. How many website Cloudflare power? Cloudflare powers millions of internet properties. Yes, same thing. So, having developer friendly interface, okay. As an example, we were able to add core functionality like new protocol. And another thing is that they have built architecture which is a pluggable. You can plug parts, like you can handle the security features by plugging uh, things. You can change, like you can use WebSocket, gRPC, or HTTP2. So you can plug and change things. You can use different storage systems. So whole architecture is changed into a pluggable architecture. Pingora consumes about 70% less, same thing, given the connection we use is there. So CPU and memory would be reduced, given that otherwise CPU and memory would be occupied waiting for the response to come. Safer, agree. So I guess this is all. And another open sourcing article. Today, we are proud to open source Pingora or Rust frameworks we have been using to build services. I guess we would cover this in another article. Um, let's take a pause here. We have gone through too much of material today. So, in simple term, like there are multiple, we would use their images itself, which is easier to understand. So we have a multiple clients, and Nginx, like Nginx uses by default uses one worker per core. So if you have a machine which has a three core, so there are three workers, and each worker would create different connections to a server, and this created connection is causing the issue, because if a request comes to this and if it goes to this, a new connection is created, and which is leading to a more CPU uses, more memory uses, and it is increasing the TTFP. So they have tried to do this where all the requests coming to Pingora, and Pingora is using the connection pool which is reused. So if a request has come to Pingora, there is one connection established, and if a request comes, it is assigned to a different thread, but the connection reuse is there. So that way they are able to reduce the CPU and memory uses by one third, and they have architecturally changed other things as well, like allowing pluggable placeholders, so you can manage different parts. It's like same thing like Express allows us to pass a request and response and then put middlewares and process things. Same things they have started allowing, and so developers can decide to plug and play with things. I guess that is all. So yeah, thank you. Let's wind it up here. Uh, we have learned a lot today. Thank you.